Prove by mathematical induction that the sum from R1 to n of R is n times n plus 1 over 2. We've already done this by a direct proof. This is like proving the sum of all the natural numbers. The only one of the problems with mathematical induction, you do actually have to know the final result in order to prove it. However, here we go. So the proposition is that the sum for R1 of R, and let's write out a few terms of this. So the first term would be 1, the next one would be 2, the next one would be 3, and then so on up until n, is equal to n times n plus 1 over 2. First step is you have to prove it true for some value, so it's easiest to take the first value, which is 1. The left-hand side is equal to 1, and the right-hand side, when n is equal to 1, so you substitute n is equal to 1 in here, you get 1, 1 plus 1 makes 2, 2 over 2 makes 1. Therefore, the result is true for n is equal to 1. Don't forget to write in what you're doing. Right, then what we do is we assume true for some value, and we say that value is k. So what we are saying is 1 plus 2 plus 3 plus all the way up to k will be equal to k plus 1 over 2. So we replaced our n with k. And then what we do is we now say we prove true for n is equal to k plus 1. So we take this and we add another term in k plus 1, and then we add this same term to the right hand side as well. So we get 1 plus 2 plus 3 plus k, adding in k plus 1 will be equal to the sum of all this bit plus another k plus 1 because we've added in k plus 1. Now if we put that over a common denominator, we get k times k plus 1 plus 2 times k plus 1. Now rather than multiplying out, we can see that k plus 1 is a common factor, so it's all over 2 still. We get k plus 1, and then we just get k plus 2 over 2. Therefore, the result is true for n is equal to k plus 1. Let's see why. Well, if we put k plus 1 there instead of k, we get k plus 1. And if we put k plus 1 instead of k here, we get k plus 1, which is k plus 2, which is what we would expect. Then don't forget to write out the conclusion. The result is true for n is equal to 1, and if it's true for n is equal to k, it is also true for n is equal to k plus 1. And therefore, the result is true for all n belonging to positive integers by the principle of mathematical induction. So what we're saying, if it's true for n is equal to 1, it's also true for the next value, which will be k plus 1, but k plus 1 in this case will be 2. If it's true for 2, then it's true for the next value, which is 3. And if it's true for 3, then it's true for the next value, which is 4, and so on, for all positive integers. Okay, so this has been a video to show you how to prove the sum of all the natural numbers by mathematical induction. I hope you've understood, and I thank you very much for watching.